So let's look at another example. And I'll be honest, I would think, I won't say all the time, but a good portion of the time, you're going to have the process of elimination is going to be the one that's most easiest to use instead of substitution. But you need to know how to do both in case you need both. So if we look at this system, if we look at the first one, just going back to our classifying again, we have a plus between our two squared terms and they're the same coefficient. So we have a circle again, we have a plus. Both of our squared terms are positive, but we have different coefficients. So we have a circle and an ellipse, okay? So then we need to think about up to 4 solutions are possible with a circle and an ellipse. May not have that many, but we know we have that possibility, okay? So if I'm looking at these two problems, I would suggest using elimination, okay? And the reason why I would suggest using elimination, just off the bat, the x squared terms are almost already eliminated because of because they're the same coefficient, just they're same signs. So that would be a key thing that they're easy to eliminate. The y squareds would also be easy to eliminate by just multiplying the top one by a -9. So this is why elimination, in my opinion, is the easiest method. So I'm just going to multiply the first one by -1 so that our x squared terms will eliminate. So that gives us -x squared minus y squared plus 10x plus 7y minus 7 equals 0. So we're going to remember elimination is just a big addition problem of our like terms. So we have x squared minus x squared. They're eliminated, which is what we wanted. 9 plus -1 is 8y squared. -10 plus 10, they eliminate as well. -63 plus 7 is -54y. That's not right. Let's try -56y. I can't subtract today apparently. And then -137 and -7 would be -144. Okay. So now we have an equation with only one set of variables, either y's or x's. So now I can solve this. Again, you could factor it if possible. You could complete the square. So either way is fine. I would go ahead and personally just complete the square because 8 goes into all of those values. So I would divide everything by 8. So y squared minus 7y minus 18 equals 0. Okay, and now I'm just going to complete the square. So I have y squared minus 7y plus, and I'm going to go ahead and move my 18 over there, so half of 7. So this is kind of a yucky one, but it's going to be okay. So 7 halves squared would be 49 fourths, and that's what we're going to add to both sides. Okay, so we have y minus 7 halves squared equals, if we add those together, and I don't know that one off the top of my head, is 121 fourths. Okay, so then we're going to take the square root. So y minus 7 halves equals positive or negative. These are both perfect squares, 11 halves. So we're going to add 7 halves to both sides. So we have y equals 11 halves plus 7 halves. So 11 plus 7 is 18 divided by 2 is 9. And y equals -11 halves plus 7 is -4 halves, which is -2. So we know we have two y values, so therefore we're going to have two sets of ordered pairs that are solutions. So we have a y value of 9 and a y value of -2. So now we have two different substitution problems to do. Okay, so I'm going to erase some of this so that we can have a little room to work. Okay, so we're going to sub in 9 for our y value. And again, it doesn't matter which one you would do. The first equation just looks easier to me because it's smaller numbers. So I have x squared plus 9 squared minus 10x minus 7 times 9 plus 7 equals 0. Okay, so we have x squared plus 81 minus 10x minus 63 plus 7 equals 0. So I have x squared minus 10x, and then we have 81 minus 63 plus 7. So that's positive 25 equals 0. Okay, so that's pretty easy to factor because the product being 25, the sum being 10, it have to be 5 and 5. So that's a perfect square trinomial, not 2. It would be 5 squared equals 0. So then you could take the square root. So x minus 5 equals 0. So x equals 5. So 5, 9 is one of the ordered pairs. And then if we work out the second one, we have to put negative 2 in for y. So we're going to say x squared plus negative 2 squared minus 10x minus 7 times negative 2 plus 7 equals 0. So we're doing the same process, just with a different value. So now we have x squared minus 10x, and then we have what? 4 plus 14 plus 7. So again, that's 25, right? 4 plus 14 is 18 plus 7 is 25, yep. So again, that's another perfect square trinomial. So we know x is equal to 5. So at 5, 9, and at 5, negative 2, though that circle and ellipse would intersect. So although we could have up to 4 solutions, we only had 2 solutions in this particular problem. Okay, so now you're going to go into solve the next one in the manner in which you think you should do it, and then you work on delta math.